Hello, uh, I am Crash Master and I am going to take the PCD of Starters 210. This is Division 4. I usually participate in Division 2, which is this one. Just a second. I usually participate here. I was able to solve the first three questions and I felt this one was easier, but I was not able to solve it. But yeah, I'll discuss it in Div 4 for the first two questions, and rest three I'll discuss it in Div 2. So yeah, uh, now for Div 4. This is the first question, notebook counting. So basically, Chef has A notebooks, each has B pages. Each page has a front side and a back side, and each side has 50 lines drawn on it. So total there are 100 lines on one page. There are B pages, B number of pages, and A number of books. So we just simply multiply A into B into 100 to get the final answer. This is the code, and it, as you can see, on submitting it, hit submission queued. Correct answer. We got an AC. So this is the first question. Very easy. Next is profits. Chef is running a lemonade stand. Each lemonade costs X rupees to make, and he has a total of n customers, and the ith customer will spend I rupees on one lemonade, and he wants to maximize his profit. Okay, so if somebody wants to maximize their profit, it means that they would prefer not to take a loss, and it is okay if you sell zero lemonades. It is totally okay if you sell zero lemonades. Like here we see a test case where we are selling zero lemonades. Let's just take this test case for like a while, and I'll explain this test case. So this is a test case. The first guy comes with 1 rupee, second guy with 2, third with 3, fourth with 4, fifth with 5. There are only 5 people, and one lemonade costs 6 rupees to make. So will I sell it to the first lemonade? If I do sell it to the first guy, I will incur a loss of 5 rupees, which I do not want. This will be minus 5, which I do not want to happen. Basically what we will do, we will skip till we get to 6. So say instead of here 5, there were 6, 7, 8 as well. So we will just count nothing till this part. We will not give any of these guys any lemonades, and we'll give only these guys lemonades. So this guy will give 1 rupee and this guy will give 2 rupees as profit. Total profit becomes 3 rupees. So that is pretty much what I did, and input here, the input is in AB, and my submissions I just did right now because I am in div 2 and this was div 4. Let's see the submission, and obviously it status AC. I got an AC on that. Right, so here we took the input A and B. Uh, this is my counter variable, so the total number that I have taken, the total profit that I have got till now. Uh, as long as the number that I am at is lesser than or equal to B, the cost that I need to make lemonade, I will do a continue. Else, I will add it to my counter variable. How will I add it? The current amount that my customer is going to give me, which is I, minus the cost that it takes for me to make a lemonade. This will give me the profit on that lemonade. So I added it to C, and finally I CO. I just outputted this. If the constraints were a bit closer, I would have just put here as I would have just either just put here as C, this just put here as B plus B plus 1, sorry, and that will also work. Otherwise, I'll just do AP, the formula of arithmetic sum of arithmetic progressions, and that will also work. So yeah, you will get the AP sum of AP through in O of 1. This is still O of n. So yeah, the AP is most optimal, and I just did this because it is quick. So yeah, that was the solution for that one. Now moving on to diff 2. Okay, diff 2. Diff 2 question 1, chocolate eating. If chef has A milk chocolates, A dark chocolates, and you'll repeat that process A plus B times. Cool. So basically what I thought of was uh, sorry, what is, and we have to find this maximum possible satisfaction. Let's take a test case, any test case. For example, let's take this one. Wait, let's take all these three. I'll try run them. Yep, and these are the test cases. Now that this is the milk chocolate, I think this is the dark chocolate. Yep, yep, that is one is milk. So from pure observation of these test cases, look at this. Uh, 1 plus 2 equals 3. Here is 3. And 4 plus 2 equals 6. There is 6. So from pure observation, I have figured this out. Otherwise, the proper, so I just simply did, if it is equal, C out n minus 1, it's sum minus 1. If it is not equal, straight up C out the sum. Uh, a proper kind of provy type method would be something like uh, okay. See, there are, you have A milk chocolates, B dark chocolates. Okay, so you will first eat all the dark chocolates. So you will have 0, 1, next iteration 0, 2. Now, if you eat all the milk chocolates, you eat whichever is the higher one. Basically, that's the point I'm making. If you eat the higher one, the lower one has no way to catch up with that one. So your satisfaction still remains the maximum. So here, since 2-1, now you can get 2-1, and there is no loss of satisfaction. Total satisfaction would be 3. But in this case, 1-1 ka case, if you eat any one of them first, then you will have a case where you will get this. Now this will give you 0 satisfaction. This case will give you 0 satisfaction. This case will give you 1 satisfaction. Total satisfaction would be 2. Sorry, 1. 1 will be a total satisfaction. That's what is happening when it is equal. When it is not equal, you eat the higher one first. You eat all the 4 first. 2 cannot become equal to 4. So you will then eat all the 2's. Total satisfaction would be 6. And yep, that's it. Submission. Yep, that's what I did. If it is equal to it, then I simply see out minus a plus b minus 1, else a plus b. So that's for the first question. The second one was, if there are if there is an array of n distinct integers, define f of x, which is the minimum value of this. If, in case there are multiple indices with the minimum one, choose the one. Oh, this was a bit tricky. For this, what I did was, let's take this case. This has one observation that is very important for you to make. Now paste. Huh. So observation is, if I have anything above the maximum number, let's just say maximum number, in this case it is 5. Okay, the maximum number is 5, so anything above 5, take 6, 7, 8, 9, 10, any number. There are infinite numbers more than 5, so any number more than 5 will be the closest number to 5. Fair enough, because 5 is the closest to them, and 2 would lie 2 would lie somewhere here, which is farther away from all those numbers greater than 5. So 5 is the closest one, and since there are multiple such integers here, in case the answer is infinite for some index I, we output -1. The total number of numbers greater than 5 is infinity, so we output -1. Similar thing would occur for the lowest element, which is 2. To the number of numbers lesser than 2 are infinite, so it will also get -1. Here, since there are only two numbers, the output in the first case, your output would be -1 and -1. Cool, cool. Now, while implementing, I did something kinda dumb, kinda smart, no idea, but yeah. Oh, and one more important thing. Here, where did the question go? Yep, there's a question. Right. Uh, huh. In case there are multiple indices I with the minimum value, choose the one with the smallest value of AI. Basically, what is happening here is this will occur in these two cases. Let me just take one of them. Yep. So 2, 3, 4, 5, 7, 9, 10. So let's just take 3. 3 is closer to 2, but at the same time 2 already has these infinite numbers lesser than 2. So we are not going to count for 2's, but for 7's. 7 is the only number that we can give an output for in this case, in the second test case. 4. 4 is 4 closer to 7 or is 4 closer to 2? It is closer to 2 because there is only one number in between them. On the other hand, there are two numbers. Common sense. So 5 and 6 are closer to 7 and 8 is closer to 7. So this is kind of straightforward. Your initial value would be C, which is 1. Initial value counter would be 1, which is this one. No, nothing normal. So initial counter value will be 1, and then you will count for these two. Basically, you will do 7 minus 2, which is 4. 4 divided by 2 is 2, and hence take these two. And similarly, sorry, 7 minus 2 is 5. 5 divided by 2 floor is 2, so you will take these two. And similarly for this, 10 minus 7 is 3, and uska floor is 1, so this one 8 1. Floor क्या था? So yeah, sorry, one more thing, but this same logic does not work here. In this case, I will, yeah, in this case. Why does it not work? 2, 3, 4. Yeah, I'm just not going to do it till 14, but similar thing would occur. Uh, yeah, similar thing would occur between 14 to 16, just with a slight difference. So basically, till 14, the number of numbers inside is odd. these are odd, total number of numbers. But on the other hand, this was even. Since this was even, it could be cleanly split into two, which is 3 4 is one group and 5 6 is one group. This will not be cleanly split into one group. Instead of what will happen is uh, 3 4 5 6 7 will be closer to 2 compared to 14. 8 9 10 11 12 5 and 5 here. 8 9 10 11 12 will be closer to 14, but 8 on the other hand would be equidistant to both 2 and 14. And here it was mentioned that if there are indices with minimum value, which was if there are multiple indices I with the minimum value, choose the one with the smallest I. Yeah. So this 8 will choose to go with 2 instead of 14. So that will just be the only change. So there we just do C minus minus. Or when it is greater, like till 26 here, if I extend this same thing, 26. Here there will also again be an integer which will be equidistant, but that integer will choose 14. So how did I implement this? Submissions. Yep, there. I took a vector of pairs so that I was able to take in the original indices. I was able to keep a track of the original indices. Cn, and here I kept a track of the original indices. I sorted everything. Then I used an answer vector. So as I have previously explained, the first one, the smallest one will be 0, sorry, minus 1, and the largest one will also be minus 1 because there are infinite number of integers. After that, as the integers between them. So if this is a counter variable, C is a counter variable. Basically, what I did here was checked if this part is greater than this part. Mainly, I have to add this part to my counter variable because this will be total number of indices which are closer to one of them. The issue happens here because I'm comparing the AI with the smaller one, and since it's a smaller one, the one at the center will go to the smaller one instead of the bigger one. So here I checked if that division, if that subtraction is an even number. If it is an even number, then there will be a middle. Basically, the number in between those two numbers will be odd. The numbers, the number of numbers between those two numbers will be odd. So C minus minus. Here there is no need to do a C minus minus because the smaller one is the A of I that I'm currently searching on. So that was it. I just used that and see out, and again AC. I got an all clear, all, all correct. Sorry. So that was the first question. So second question, pretty easy again. Third question was kind of smart. Uh, Third question was here is the basic definition of what exactly it means to be balanced string. Balanced string is an empty string. First off, it is an empty string. So here S, if S is empty, let's say, then S is balanced, and since it is balanced, we can get 0 1 because there is nothing between 0 and 1. So hence that is balanced. You can add a 0 on the left side and 1 on the right side. Similarly, you can build this by concatenation of 0 1 and a separate 0 1, two 0 1s. This one you can, the third one, you can build it by getting a 0 1 as we have previously solved here. And then since 0 1 is beautiful, we can put a 0 at the beginning and 1 at the end. Cool, cool. Now, so basically, in the question, we are asked to find the minimum number of operations to make S balanced, and we can remove the elements in a sorted or sorted subsequence. Subsequence means the exact order does not matter, but we have to go from 0 to n. Okay, we cannot go for we cannot jump inside, but we can only jump ahead. We cannot go backwards. Basically, that is what is meant by subsequence. Subsequence means it does not necessarily need to be continuous. Just remember that. I messed up explaining, but yeah, it may not necessarily be a continuous thing. So let's take an example. 0 1. 0 1 we have as seen that it is beautiful, as we have already seen that it is beautiful. Now, what will not be beautiful? Let's say if there is a 1 ahead, then that will not be beautiful irrespective of how many zeros there are behind it. Cool? Because this one has nobody to pair up with. Uh, that is why this one will not be beautiful. So I just took an idea of how many ones there are there before my zeros start. Now here is my thinking with 0. I'll give you a random number. Yep. And let me just check one thing. Random string I meant. Yep, that string works. Now let's see how many beautiful ones there are that we can just straight up remove. So this is beautiful. We can remove this, and this whole thing we can remove since these two are visibly beautiful. If we can just straight up see, this is given in that example up there. Now here comes a tricky part. To be honest, let's just keep it like this. So here comes the tricky part. Here this one is beautiful, that is we have already seen. This whole thing till here is beautiful. Now the observation that I'm making or claiming is if there is a positive number of zeros before the current ones, and every single one will cancel out 1 0. Every single one will get paired up with at 1 0. So if there are a positive number of ones, there will not be any positive number of zeros still remaining to be paired up with. There will not be any ones here. Any ones which are wrongly placed at the end. Fair enough? Now, here's the thing why I'm making this assumption. Like, let me prove that thing, prove my thinking to you. So, a random sequence 0 1 1 1 0 1 0 0. Yep, that seems pretty random. So, this one will get paired. These two, on the other hand, are wrongly placed. You have no other choice but to remove them. So while removing, I basically save this in a separate vector, and then here we find the first one. So the first 0, second 0, but yeah, for our current first 0. So this one will get paired up again because it is just adjacent to it. Again, paired up. These line of zeros, they do not have anything to pair up with. So I will assume at the moment that they are a part of the beautiful sequence, and they will be later on be paired up with some of the other, if and maybe there are ones afterwards. There are sufficient number of ones afterwards. here in this case there weren't sufficient number of ones. Here three ones and sorry, these guys get paired up straight away. And to make it beautiful, as we have seen here, we can add 1 0 and 1 1 at the beginning and end respectively. Since sorry, this part is beautiful, we are going to assume that these parts I added since they were beautiful. Along with them I concatenated them. So my current logic is maintain a running count of the number of zeros that I have. When I encounter a 1, I'll decrease the number of zeros. That number of zeros is my number of unpaired zeros. So I'll decrease that. When I encounter another 0, I'll straight up increase my number of unpaired zeros. For each one, I'll decrease them. Now, case 1. Let's say there are... Okay, this is... I hope you understood this example. So this is not beautiful, and if we remove this 1 0, then this will become beautiful. Why? Because these 4 will get paired up, and these two we will assume that they were added because of this, the second point. So yeah, that's case 1, and this is the final output for the original case. The final output for this would be 1 because I just needed to remove 1 0, and since 1 0 is always sorted, so yeah. In this case, let's see, in the second case, these two will get paired up, so my current zeros, count of unpaired zeros till now here is 0, but I have two unpaired ones, and as we have discussed earlier, I cannot have ones in the beginning as the very first element or something. I cannot have that, so I cannot have a 1 before I get any zeros, and unpaired zeros, this one is already paired up. So this will go into my vector, like to say that there are ones present there. You can also make it a boolean, you don't necessarily need to make it vector. Boolean will just check if there are ones like these which occur before any zeros. So yeah, there are ones. Now this 0, it cannot get paired up to like this. It can only get paired up ahead. So this will be the pairing it will make. Similarly for all of them. We have got till here. Cool. Now here there are 1 2 3 4 5 zeros, and there are none zeros coming from behind. So there are 5 zeros that need to get paired up with. I see a 1, I decrease the number of zeros. Now there are 4 zeros. 0 5 1 4 5 4 5. Cool. Now the current 5 will get paired up with these one at a time. So these guys will get paired up. Now here is the thing. There is one remaining in the behind at the last one, and there are these two ones. And since all of them are ones, I can just straight up pick them up. Observation or hypothesis or guess kind of was if the current count of zeros, unpaired zeros, is positive, I cannot have any ones at the end. That was my thinking, because all the zeros will get paired up with those remaining ones. So either my current count of zeros will no longer be greater than or equal to 0, or it will be greater than or equal to 0. It will be greater than 0, and the current number of ones would at the end, the unpaired ones would be 0. So that was the thing, that was my thinking. That was the main part that we have to see here in this question. So as I had said before, I just put a vector, even a bool would have worked. to check if there is a 1 which is unpaired in the beginning, and then I put a counter variable for 0. I counted zeros, and when I found a 1 I subtracted that. Yeah, that worked. I got an AC for that. Yep. Just a second. Yep, so here it is. LLN, CNN, CN string, and here's a vector. I could have even turned this into a boolean, but yeah. If my current element is a 1 and my number of zeros till now is 0, I'll just simply convert this into a 1. Since this is LL, this is not a character, I'll just convert this into int and then I'll push it back here into LL. Else, if the current is 1 and my count of zeros is not 0, I'll just do C minus count minus minus. Why did I do count minus? That means that 1 got paired up with the 0 that was remaining. Any 0, at least 1 0 was remaining, it got paired. Here again, same thing. If I find a 0, I increase my count variable. Now here comes the part. If b, the size of b is equal to 0, sorry, if the b vector is empty, what does that mean? There are no misplaced ones in the beginning or in the very end. And since c of 0, counter variable number of zeros is also 0, that means that there are no ones remaining at the end, basically, and no zeros remaining either. Sorry, there can be ones remaining, but there are no zeros remaining. And from b dot size, we have established that there are no ones remaining at the end. Same here. If c of 0 is not equal to 0, then that means there is at least one 0 which is not placed correctly. And since it is a 0, it does not necessarily need to be sorted as such. So you can just straight up go there and have food. So have food what? You can. Okay, sorry, I messed up a bit. I lost track. And I'm highly sleepy. And I guess hungry as well. No idea why I just had my dinner right now. So yeah, that was the case of B is empty, but C is not empty. Since C is not empty, it is basically zeros which are not correctly placed. You can just pick up those zeros and C out 1, since we do not need the exact order. Order does not matter. All zeros are equal. In this case, in third case, B size is not equal to 0. That means there are ones which are wrongly placed. And since C equals 0, that could mean ones are placed at the end, very end, or at the very beginning, anywhere. So yeah, hence we can just straight up pick up all the ones, C out 1. Now here comes the smart part. If both of them are non-zeros, what does that mean? If C of 0 is non-zero, that means at the very end there are no ones remaining as such. All the ones that are there are concentrated at the very beginning, before I found a 0, before I found my first zeros. So yeah, it is concentrated in the very beginning. Hence, since it is in the beginning, as we had discussed earlier about subsequences, the meaning of subsequences, it means I follow the same order, but not necessarily. I can jump forward, but I cannot go backward, basically. So yeah, that was that. If p of size is not equal to 0, all my unpaired ones will be concentrated in the very beginning, and since C of 0 is also not equal to 0, it is considered in the very end as well. Sorry, there are zeros remaining after everything is taken care of. What does that mean? The zeros are after the ones. Cool, cool. So if the zeros are after the ones, that means I cannot take. See, if the zeros are after one, that means I cannot take both of them together. So I'll have to split it up into two operations. Hence, C out 2. That is B. So yeah, that is the PCD. If you guys have any questions, doubts, or anything, uh, comment section. Feel free to put it in the comment section. And yeah, I did not. I haven't attempted a mini modular subarray. I did not get the time to. I was spent way too long on make all this question. I kind of wasted a lot of time. This seems easy. It is constructive mainly, but I haven't solved even this one yet. So yeah, that is basically it for the PCD. I'm done. Sayonara and good night.